Again, my name is Sal Stangaroni with TEC. I am in the controls department here for doing DDC controls. And today we are going to be talking about the VVT Open Controller. And we're going to actually be doing some hands-on programming and commissioning of one of these controllers here. So this is going to be completely informal, guys. If you have any questions at any time, just type it in the questions box. I'll try to get to it. Otherwise, I'll get to it at the end. And let's get started here. So real quick, we're just going to review a VVT system. VVT stands for variable volume and temperature. There's a lot of other names that you could hear from different manufacturers, but Carrier coined the name VVT. What that stands for is variable volume and temperature. And it's variable volume because you have zone dampers that are actually varying the volume of air delivered to different spaces. And it's called variable temperature because you have a rooftop unit or air source that is varying the temperature to each of those zones. And that is done through a voting system that we will talk about, but just a little intro. General applications, anything under 20-25 tons would be appropriate for this. Once you get up that high, you really would want to look at doing a VFD or VAV type system. But anything below 20 tons is kind of more a VVT system because you don't have a cooling load at all times here. So you can see small to medium zones. You can get approximately 3 to 15 zones. Yeah, technically we have a limit of up to 32 zones on all of our VVT systems per unit, but generally you don't see that often. I mean, that gets a little expensive and you got too much control. And then, yeah, 1/4 to 2.5 tons per zone, 0 to 100, or 100 to 1,000 CFM per zone. These are just approximate numbers if you guys are actually designing VVT systems. But doing this presentation, we're kind of assuming that you guys have some background on VVT and that you're just looking at doing the programming here. So here's kind of just a conceptual layout of it. Just to wrap your head around it, you got a rooftop unit providing the air. You have your 4 different zones that are regulating the air or varying the air to the space, and you have a bypass damper that is regulating the duct static pressure in the system so that you're not blowing ductwork out. Again, this is just basics here. We're going to look at 3 controllers today. We're not going to get too detailed on one of them, which would be this R2 Open controller. This is a controller that's actually controlling the air source for our system, okay? We did a separate webinar on programming this that you guys can reference if you have questions, but we're going to see there's a couple things you need to do in order to set up linkage and do some commissioning of the VVTs. So I just wanted to give you a little picture of it. It's called the RT Open Controller. It ties into a thermostat terminal board on a rooftop unit. It can be a Carrier unit, but it can be any type of rooftop unit that has a thermostat terminal board. You got 2 stages of heat, 2 stages of cooling, economizer control, power exhaust control, and it can do the new 2-stage VFD control that Carrier's come out with. And supporting linkage. Linkage we will talk about in more detail later, but linkage is the communication that Carrier came up with between each of the zones and the air source. And it's pretty neat, so we'll see it here soon. The 2 other controllers we're going to look at here are the VVT Open Zone Controller and the VVT Open Bypass Controller. In order to have a VVT system with our Carrier Open product line, you will need both of these controllers, at least one of each. And you can see the different options on them. The Zone Controller can do 2 stages, up to 2 stages of heat or modulating heat control. It monitors discharge air temperature. It can also do a fan control as well if you have a fan-powered zone. You don't usually see that, but it's possible. You can see that the actuators are actually built into each of the controllers. So this would slap right on the damper shaft of the zone controller, and then you would wire to it from there. You do have the ability to slave an actuator off of this if, for instance, you have a very large damper that needs a higher torque actuator. These actuators are, I think, 35 pounds per square inch of torque, so it is a lot of torque. You shouldn't really run into dampers that need high torque actuators, but the option is there for these controllers. And you can get them field installed or factory installed on dampers, okay? And then for the bypass controller, a little bit different. The main thing are these 2 pressure inputs on the right-hand side. That is to monitor the duct static pressure to maintain a set point, and you guys will see that a little bit later here. But it is also monitoring discharge air temperature. You can also slave an actuator. A lot of times you'll see actuators slaved more on bypass dampers because they can be larger depending on the system. And last but not least, before we get into the actual zone, the actual programming here, we are going to look at just a sample wiring diagram of one of these zone controllers. So you can see this would be a typical wiring diagram we would provide to you guys so that you could do the installation and then the programming, but we just kind of give this as a little helpful guide here for you. But you can see just starting looking through the inputs outputs of the controller here, starting from the right hand side, you can see you have your 24 volt power coming to the controller. Every carrier controller requires 24 volt power in the open line, and every controller has to have a dedicated transformer. Technically, you can try to run the system without it, but in order to maintain your warranty, you need to have a dedicated transformer for every controller. Okay. So you have your 2-wired power connection is your first input here. Moving to the left of that, this is your actual communication input, which is a BACnet network. The BACnet network that we can run on has to be 22 gauge shielded 2-conductor wire. Okay, so you can see you have your 2 conductors, your positive and your negative, going into 1 and 2 on that plug, and then you have your shield that actually lands on our terminal as well. If you guys, you probably know this, but on most communication, if you have a shield, usually one side of it is grounded and the other is left hanging. On our system, you can land the shield on every controller and it will ground internally and on one side and remain hanging on the other. So don't have to worry about taping up a shield wire there. We're going to zoom in a little bit here to see some of these other plugs. The next plug would be an RNet sensor, which is one of the different space temperature options that you can use with these controllers, and I'll show you those in a minute here. But it is a 4-wire connection, and the good part about these sensors for these controllers is that there's a plug input in the bottom of them where you can plug in the field assistant servicing software, and you can access the entire system to do programming. So rather than having to go up in the ceiling and plugging in your field assistant to that controller, you can actually plug to the bottom of it and do programming from the space. So if you have one of those 4-wire sensors that goes into this RNet plug, it is very helpful and very easy to do troubleshooting. But moving on here, the next plug, this is where you'd wire your supplier temperature sensor into input 1 and 2. You need a supplier sensor in order for one of these to function. It's important because it needs to know what type of air is coming to the damper, and based on that, it knows how to function, how to regulate the air to the space. So if you have cold air coming and your zone needs heat, that zone damper is going to close, and vice versa. So you need a supplier temperature sensor. The input next to that would be for a remote contact enable. I've never set up a system like this, but you can have, for instance, if you wanted the zone to become occupied when someone actually walked into the zone, you could wire, say, a light switch into this input, and whenever that light switch closed or turned on, then this zone would go into occupied mode. Usually these are done through scheduling time schedules, which we'll look at, but this is another option that the controller is capable of to regulate the occupied mode. The next plug moving over is where you can use a different option of a space temperature sensor. Okay, so like I said before, there's the carrier communicating sensor, which is called an RNet sensor, which is this 4-plug here. If we look at the other 4-plug we're on, we have, you'll see 4 inputs here. We have T55 and ground. That would be where you would wire in a different type of temperature sensor, and that type has to be what's called a 10K Type 2 thermistor. That is the type of sensor that will function with this controller. So you can buy them from anywhere. You can buy them from Carrier, ACI, but it has to be a 10K Type 2 thermistor in order to wire to that. The next input is for monitoring relative humidity or CO2 in the space. Okay, so it is expensive, but the best way to do demand control ventilation with a zoning system is by having a space CO2 sensor, and this is where you would wire it in. This would be a 4 to 20 milliamp signal, or a 0 to 5 volt, or 0 to 10 volt signal. It is something that you can use for, you can use any of those options. They're all selectable here, so depending on what type of sensor you have. But if we look at the wiring really quick, what we have wired into this here, tracing from plug 2, we have our Supplier temperature sensor. You can see down here this probe sensor that gets mounted in the duct. And then if we look at T55 and ground, this is our thermistor sensor that is actually wired to a combo CO2 temperature sensor. Okay, this is a part that we sell here that can do both temperature sensing and CO2. So you'll see this J5 plug right here is actually bringing the temperature, the thermistor reading to the controller, and this J4 plug is bringing the CO2. Any CO2 sensor that you're going to have wired into these requires a dedicated transformer, okay, which is why you see this is a separate transformer powering this CO2 sensor, okay. Carrier will not allow you to, your warranty for the controller will be void if you have the same power source powering a CO2 sensor as well as a controller, so it's required to have a dedicated transformer. So moving on here, the last two plugs we have on here are actual outputs from the controller, and these are for reheat or slaving an actuator. So if we zoom in a little bit here, we have one analog output that is labeled as hot water valve, and this would be for modulating a hot water valve or for an SCR type control or a modulating electric heat control, okay? So this sends out a 0 to 10 volt signal, which you'd wire to a hot water valve or to a input on an SCR control to do reheat. You don't always see reheat in VVT systems. It's usually not required because the rooftop unit can provide both heating and cooling, but it is an option. And the last four outputs we have on here are actual contactors for heat stages. Okay, so if you have electric heat, you can do both ducted or baseboard heat, which we'll see here in a minute, but you have a contactor for heat stage 1, heat stage 2, and fan. And this bus terminal is actually where the 24 volt power gets wired into it so that it can send that 24 volts through the contactor to enable your reheat. So that's kind of just the general layout of these zone controllers. We're going to go through the actual programming of them here soon. Just one more thing I want to note to you guys. You'll see these rotary switches here and these dip switches. Okay, the dip switches are used to set the baud rate of how the communication speaks, how fast it speaks. Okay, so you have four different options. If you can see on this MSTP baud, you have 9600, 19.2, 38.4, or 76.8. For baud rate, it really depends on what type of system you have, but in my experience, using 76.8 is the fastest for programming, commissioning, and speaking. So that's what I like to use, but you can select it based on these two dip switches, 1 and 2 here. And then these rotary switches are for setting the address of the zone controller. Addressing is very important for setting up linkage and the communication between the zone controller and the air source. So we're going to talk about it in more detail later, but each controller on this network has to have a dedicated address. If you have two of the same address, they're not going to be able to communicate with the system, and you're not going to have functionality. Okay, so this is where you can set them on the controller. You can go up to 99 addresses with these. So one is for the tens digit, one is for the ones digit here. So kind of just a layout here. We're going to go, the next page is kind of going to show you those space temperature sensors I was talking about, the carrier communicating space temperature sensors. There's 4 different options, but every option has an input on the bottom to plug in the field assistant servicing tool, okay, and allow you to pull up the entire communication network with that tool. But you'll see the standard one has just no buttons. It's just a regular no display sensor. Then you have one with a slide bar and override. And then you have one with a digital display that can do manual override, warm or cooler. And then the final one is used for fan coils and unit ventilators where you have multiple speeds of a fan. You can actually choose your fan speed on there. So you can go from low to medium to high. But other than that, we're actually going to jump right in here. Close this, and I'm going to show you just the installation manuals for the VVT open and bypass controllers. These manuals have a detailed list of all the configurations we're going to go through today. And yes, Dan Moore just asked a question if the presentation will be available. We will be sending out a PDF of the presentation if requested. So let me know and I can send you just the quick little PDF I was looking through there. But we'll also have a video copy posted on the website as well. But these installation manuals are huge for doing what we're going to do today. If we look, there are tables that talk about every single configuration we're going to go through. Okay, it's called basically says configuring the VVT zone controller properties. These outline all the properties we're going to look at and what they mean and how they affect the control of the unit. Okay, so if you're programming on site and you forget what something means or you need help with something, these installation manuals are where you want to go in order to understand first. And then if you can't understand from there, you can give us a call and we can help you out. So with that, we are going to go to Field Assistant Servicing Tool, and we are going to do a live demo with some commissioning of the VVT zone controller. So you can see I set up a system name webinar demo here, and I've got my communication port, which is to my USB port. If you guys aren't familiar with this Field Assistant Servicing Tool, I covered it in the RTU Open installation manual, or I'm sorry, RTU Open webinar that we have posted on our website of how to use it. And we can, if you have the software, give us a call. We'd be happy to help you out with anything you need. But I just want to make sure we have the right time here, and I'm the right communication port for what USB I'm plugged into. And I'm going to hit this play button, and we are going to connect to the network. This is just a little network that I have set up in my office here that I'm going to be connecting to, and it's going to be live data here. So. All right. So if you guys haven't seen this software before, it's very similar to the iView, except it is not broadcast on the web. But you can see I have 3 controllers on my network on the left-hand side. I have a bypass controller, which we're looking at now. I have a zone controller, and I have my air source controller, which is my RTU open. And when I mentioned addressing before, you can see next to each controller I have the address for those. So I have 14 as my bypass, 15 as my zone, and 21 as my rooftop. Now those addresses automatically will show up based on what I have those rotary switches set for. So for the bypass I have a 1 in the tens digit and a 4 in the ones digit. And that auto detects through this software, okay? Now, we will talk about linkage when we're setting it up. Linkage is basically the communication logic that's built into these controllers so that the zone controller can speak with the other zones, collect all that information, and then send it to the air source or rooftop unit so that it knows how to function. Okay, that's what Carrier calls linkage. And doing addressing for linkage is a little bit tricky, but actually it's not that tricky. But it's very important because if you don't have the addressing correct, you will not be able to have linkage set up here. So just so you guys know, linkage runs off of what's called a master stat and slave stats. Well, master controller and slave controllers. And the master controller pulls all of the slave controllers for their information, collects it, and sends that data to the air source or rooftop unit. And then from there, the rooftop unit will decide if it should go into heating, if it should go into cooling, if it should just go into fan. And then it actually sends data back to the master stat, like what its supplier temperature sensor is, what mode it's in, and a few other parameters. And from there, the master stat sends all that information out to the slave. This is all auto-generated logic that's built into all of Carrier controllers. It's just a matter of setting it up to function and confirming that it does function, which we're going to do today. But addressing, all of the zones for linkage need to be in sequential order address-wise, okay? And the highest address has to be the master zone, and the address right below that has to be the bypass zone, okay? If you do not have the bypass in that location, you're not going to do linkage properly. and you need to set up the highest zone address as the master, okay, which we'll show you how to do. But if you can see here, I have 1514 for my sequence. If I had other zones on the system, they would have to go down starting at address 13 down through all the way to 1, depending on how many zones I had. So for instance, if I had 5 zones, I would have 15 as my master, 14 my bypass, and then I would have 13 as zone 2, 12 as zone 3, 11 as zone 4, and 10 as zone 5. Okay? You need to maintain that sequential order for all of the zone addresses, and the bypass has to be second from the top. Okay? If you don't have that set up, it's not going to do linkage properly. Now for the rooftop address, the address just has to be somewhere outside of that zone. Outside of that sequence of zone addresses. So let's say that I had the 5 zones going from 15 to 10. I could not have my rooftop controller addressed in between that 15 and 10. It has to be somewhere outside of it. Doesn't matter where, it just has to be somewhere outside of that zone, that sequence. Make sense? So I've already set up the rooftop unit to in the configuration that I want. You can see the graphic here. We're going to go into the VVT zone controller, and we're going to start programming it here. So you can see this graphic will auto-generate here. Anytime you see a box around a value, that box is a locked value. The reason I have those here is because I don't actually have temperature sensors wired in for my supplier and my space temperature, and I've just overridden the controller to think it has 70 degrees for both of those. Okay. But just looking at the graphic here, you have this is live data, and on your system when you have sensors, it's live data. But you can see the damper position is at 20%. I've got my space temperature, my supplier, and you can see my occupied set points here. Right now I'm trying to maintain 70 for heating and 74 for cooling. If I hit this arrow next to it here, I can actually adjust my heating and cooling set points right here for both my occupied period. This is my top bar, and my unoccupied period, which is my bottom bar, the gray. So for unoccupied times, for night setback, I'm maintaining 55 and 90. Okay. If I wanted to change one of these, I could bump up my cooling to 76, type it in, I hit OK. Now this value will change in a second here. Yeah, you can see now that my value's changed to 76. Okay, just takes a minute to actually take the load. So this graphic here is how you want your end user to control a zoning system. Okay, you don't want them to actually go through the configurations like we're going to do today. You want them to just be able to look at what's going on and change any set points that he would need. Okay, you shouldn't have to do anything more than that. Put this back to 74 here real quick. And we are going to go to the configuration page, which is under the Properties tab. Okay. In the Properties tab, you will see here there's a couple different tabs. The one you want to start with is the Equipment tab. Okay. And we're just going to go through. Again, all of these tables are actually in the installation manual for this controller. Okay, for the VVT Open. So you'll see unit configuration and set point properties. If we go back here and go to configuration, we have unit configuration and set point, and it actually describes what each of these values means, how it controls the system. Okay, just always have that as a reference. Make sure you have it on your computer or you have it in your truck. So looking at the first drop down here, this is the status. This kind of is just a summary of what's going on with the graphic. Okay, you can see what mode the unit's in. Right now it says it's in heating mode because of the discharge air temperature. Okay, so regardless of what the space temperature is reading, the terminal mode is determined, by what the supplier temperature from the rooftop unit is, what that sensor is reading. Okay, so if you're reading 55 degrees and your space temperature is too cold, even though you would require heat in the space, technically you're in cooling mode because that's the air that's being delivered to the space. And when something like that happens, your zone would go to its minimum position, close off so that you're not bringing in cold air and making your space colder. Okay. And that's described again in the installation manual. You can look at it too. But it gets a little confusing when you have a zone that you think needs heating, or when you think it needs cooling, but it's actually in heating mode because the air source hasn't actually switched into the cooling mode yet. You can see what kind of zone you have. This is a single duct zone. You can see what your space temperature is, what your damper position is, your supplier, your outdoor air. You can see if you're in a shutdown mode for some sort of alarm. If the zone is shut down, this will say active. You'll see a big red alarm on the graphics page saying there's something wrong. Either you lost your space temperature, or you lost your supplier, or some sort of sensor went out of whack. Something went into shutdown mode. So status, real quick, just looking at it. Actually doing the configuration and programming is under the configuration page here. So we're going to start off with unit configuration. And we have a couple different question and answers here we got. So heat enable is if you have reheat on the zone. Okay. In this case, we do not have reheat on the zone, so we're going to hit disable. Okay. I can just change the drop down. It says, do you want to continue and hit OK, or do you want to hit cancel and not make the change? I'm going to hit OK. All right. Now we have a maximum heating supplier temperature. Okay. This is referenced for if you have reheat, but with a zone system, the heating supplier temperature, you really don't want it to go above 95 degrees. Ideally, you want 90-degree discharge air coming out of one of these guys. That is per ASHRAE's recommendation. However, that's not always something that is possible with a rooftop unit. So with this supplier sensor temperature, you want to put it somewhere between, depending on how much actual reading, how much heat you're getting out of your rooftop. I usually set it at around 100 to 110, depending on how high heat readings I can get out of my rooftop unit. But if the temperature goes, the supplier goes above this value, you will go into alarm, and there will be an alarm displayed. So you kind of need to base it on the type of system you have, how much heat you have on your rooftop unit. But ideally, you want to be putting out 90-degree discharge air for heating. Okay. The filter service alarm timer would be if you have like a filter on your VAV box, you can type in a value for a timed alarm. So let's say I wanted to display an alarm every 500 hours for some sort of maintenance that someone needs to come out and change the filter. I can enter that value in there. Once I enter it, it will start counting that 500 hours, and then after that it will say dirty filter alarm. Okay. Not all zones have filters on them, so it's not the most important value there, but it's an option you can put on there. Push button override is for the zone temperature sensor. Okay, as you saw before, there's different options on the zone temp sensors that you can use. A lot of them have what's called an override button, which can override the occupancy. So for instance, if someone's staying late in a zone and the schedule only goes till, let's say, 8 p.m., if someone's in that zone after 8 p.m., they press this button, they can override the system to go into occupied mode. In the software, you can actually prevent them from doing this. Okay, so you can lock out the sensor completely from doing the override and the set point adjustment. And you saw before on those sensors, there's different types of set point adjustment. You can do slide bars or digital displays, but this is actually where you can prevent your customer from adjusting set points and occupancy locally in each zone. That's something that you need to figure out based on who your customer is, what the application is, if they have the ability to do that or not. And then you can actually change the range of set point adjustment that the customer is allowed to use here. So the set point adjustment range says 2 degrees. That means it's 2 degrees up and down from the set point. So if you saw before, we were at 70 for heating as our set point. That means I can go all the way up to 72 and all the way down to 68 for my heating set point. Okay, you can adjust that to whatever you want. Obviously, we like to recommend 2 to 3 degrees, but a lot of times the less control, the better is what we see. Next value you're going to see would be heating lockout temperature. This would be for your outdoor air lockout. If you have reheat in a zone and you don't want that reheat to run above 70 degrees outside, you don't want that heat to run whenever the outdoor air is above 70 degrees, you can type that value in and it will lock out heat. It's not always used, but it's something that you have the ability to do on here. If you just leave it and you don't have heat, it's not going to do anything, so you don't have to worry about it. Power fail restart delay is just when the controller fails, it's going to take a minute to delay actual functionality here. So it's just a safety built into it. You can make that longer if you want or shorter. We just kind of leave it on. Occupancy schedules. This is where you would set it up to run off of a schedule or not. If you don't run it off a schedule, the zone's going to remain occupied 365 days a year, 24 hours a day. Okay, so if you set this to disable, you're always going to be occupied. If you set it to enable, it's going to run off of the schedule that we're going to put on here in a second here, okay? Well, in a couple minutes. And then the last value you're going to see says T55 Override Duration. T55 is one of the carrier's temperature sensors for space. And if you remember from the wiring diagram, you could see that we wired into the T55 terminal on there, which is the 10K Type 2 thermistor. This value would be if you have a button on that sensor for override, your override duration would be for this value. Okay, so if I press that button after my zone is in unoccupied mode, I'm going to go into occupied mode for 1 hour. Okay, when you have one of the digital display sensors that we saw before, those RNet sensors, you can actually adjust this value on that sensor locally. You can go from 0 to 4 hours, I believe, every 30-minute increments. So you can actually put in that duration. But if you just have a button on there, you can set up however long you want that to be. Something you usually want to confirm with your customer. The final thing would be if you need to calibrate your sensors. Like I mentioned before, the space sensor and the supplier sensor have to be 10K Type 2 thermistors, and thermistors usually have pretty good readings, but if you wanted to offset them, for some reason, recalibrate them, you could adjust them with these adjustments here, typing them into those values. So, pretty straightforward on the unit configuration. Again, all of these values are in the table in the installation manual for reference, but right now we're going to go to the next table, which would be set points. So I showed you guys earlier on the graphics page how to change the set points. You can also change the set points from this page as well, and you can see these 5 different bars. It gives you a few more options of different set points you want. Okay, so just a kind of background on these bars, these different colors are representative of a color scheme of how far out of whack you are from set point. Okay, so the green values down the middle are you're within your set point range, you're doing great, you're green, good to go. If you look to the right of it, you got a little yellow. That means you're getting a little warm above your set point. As you go into orange, you're getting a lot warm, and then you're finally going into red, which would be too hot and basically in an alarm status. And then it's the same going on the cold side with light blue and then dark blue and then alarm. These ranges are adjustable. So if I click on this green here, I can go from 70 to 74. If I change this to 68, my green is going to go bigger, you'll see. Okay, it adjusted. Now if I wanted to change the range for the yellow period, I click on the yellow, it says 74 to 75. I can make that even bigger too. Let's say I want to be yellow for 3 degrees above my set point. Now my yellow has just increased as well. Okay, so these colors are going to show up on the graphic, and from that, it's a good way to know what your system's doing, how it's an easy way to diagnose just your space temperature. Okay, and if you did some sort of floor plan graphic with an eye view, you could put a bubble on that floor plan for each zone, and that color would be represented on that bubble. So you could see a floor plan of the whole building and see what color each of the zones are and how far out of whack they are, what temperatures they are. Okay? Now, these 4 different bars that we see here, sorry, 5 different bars, are all representing different things, okay? And you can see what they're representing on the left-hand side where it says occupied, okay? So my bottom line is for my night setback, my unoccupied set points, okay? So if I click on this gray bar here, it'll say unoccupied. This is the period that I'm going to be in unoccupied mode, okay? The bar right above that is for my occupied period, which would be this green, okay? Then the 3 bars above that are for a program that's called demand limiting or load shedding, okay? And what this does is you have to have a power meter connected to the network, and that power meter basically reads the amount of energy usage the building is doing at the current time. And based on that, when you're reaching your peak loads of energy usage, it actually sheds the set points or broadens the set points so that you're saving energy and using the equipment less. So you can see there's 3 different levels of load shed that are built into this controller. So our first level would be demand limit 1. It's called demand limiting or load shedding, where I'm adding a degree to both I'm broadening my range by a degree on each side, going from 70 to 74. I go now to 69, 75. If I go to demand limit 2, if my load gets even higher, I'm going 68, 76. And then demand limit 3, I'm going to 66, 78. These are adjustable as well, but this is just built-in logic to the controller that is available. It's just a matter of you need to have some sort of power measuring system on the network that can read the peak loads and then tell this controller when it needs to go into demand limit 1, demand limit 2, demand limit 3. But it's a great feature for energy savings. It's just a matter of you need to have the required parts on here to do that, which would be power metering. So if I continue down, you shouldn't have to worry about any of the configurations below that. If you see minimum set point separation, this value of 4, this is the minimum deadband that I need to maintain between my heating and cooling set point, okay, which is 70 to 74. I need to have 4 degrees minimum between those. If I tried to change my cooling set point to 72, that's too close within that 4 degree set point range. It's not going to take that value. It's going to switch back to 74. Now on the next screen we're going to show you how to change this value, but this is something you want to be aware of, because if you do it on this screen or on the graphics screen, just like I did, you type in a 72 and go in between this range, it's not going to take the value. You're going to think the controller is not working, but really it's just maintaining the deadband. And that deadband is there so that you are preventing changeover from heating to cooling mode all the time. Okay, you don't want to be switching. You don't want to be cooling up down to 70 degrees, and then once you get below 70, switching right into heat. You want to have a little range that you're maintaining between there. We usually try to do 2 to 4 degrees depending on the application, but it's really up to you what you need to do here with your application. The final part on this set point screen would be for optimal start. Optimal start logic is built into every carrier controller, application-specific controller. Every zone controller has it on here. And there's 2 different types, and there's different time periods. So the optimal start time period is the minimum amount of time that it can take to begin cooling or heating to its occupied set points. So 1 hour before your occupied schedule, the system will read the space temperature and calculate if it needs to enable heating or cooling earlier than the normal time. Okay. The next value in this table is optimal start type, and there's 2 different types. There's temperature compensated, and there's actually learning adaptive. And you can actually shut off optimal start if you want. A lot of times that we'll do that when we're tying these into a third-party BAS system, simply because they're either doing their own optimal start on their control side, or it does cause confusion sometimes, because when the optimal start is functioning, it will actually calculate new set points based on the time. So during the temp compensated, it will, let's say it starts an hour before your occupied time starts, it will read the space temperature and it'll say, all right, for this amount of time, I want to try to maintain 70.5 degrees on heating and 74.5 for cooling. And it's gradually going to adjust those set points until you finally get to the occupied cooling and heating set points that you need for the time being. So it's going to generally change those, and when you have a third-party BAS system reading one of these controllers, they get confused when they're trying to maintain 70 degrees on their side, but the controller is saying it's maintaining 70.5. It causes problems and confusion, and it's something that you don't want to have the headaches of dealing with, so you can just lock out your optimal start. Obviously, it's a great feature for energy savings and comfort, and you want to use optimal start, but you don't have to. The difference between them is temp compensated is just going to read the temperature and adjust based on that time. whereas learning adaptive is actually going to, there's learning algorithms built in where it's going to remember how long it took to get down to a set point on from previous temperatures on previous days, and based on that it's going to adjust itself to get to set point faster. So learning adaptive is a better way to do it, but you do have the option of how you want to do it. So learning adaptive is kind of behind the scenes. You don't have as much control and knowledge of what's going on here. So that's your set point screen. Really, I don't usually mess with this screen a lot other than the optimal start, either turning it off or turning it to learning adaptive. But I mean, your set points, you can change that all from the graphics screen as well, so not much on there. Alarm configuration you don't really want to mess with. There's not a lot in here. And alarming is a little bit more sophisticated, and you don't really need to get it going for just general commissioning. A couple things you can see here, though, is on those RNet sensors we talked about with the digital displays. They're also called SPT sensors. You can actually tell the system to display a little alarm bell on that LCD if one of these things goes into alarm. So if you see the space temperature goes into alarm, I can tell it to display that bell, or I can say ignore it and don't display that bell. And right now I have it set up to just do the dirty filter alarm, but you have the ability to do any of those right on there. So just another added feature where your customer can be looking at a sensor, seeing a little alarm bell, and say, hey, now I need to call my mechanical contractor to service the account. So, but I don't really change anything on here, the hysteresis or anything. It's all set up good to go from the factory. The big configuration page is going to be next, which is service configuration. Okay, this is where you tell the controller what type of zone damper it is controlling. All right. So you have a terminal type, which is single duct. You can do a fan, parallel, or series. Obviously, most of the time with VVT, you're going to have single duct. But the cool part about this is if I change this value, let's say I change it to series fan, and I hit OK, this is going to auto-generate the new graphic based on the selection I made. So when I switch back to the graphics page, I'm actually going to see a fan on here. Okay, you can see the fan with the filter. It will automatically change your zone graphic based on what you select on this service configuration page. Okay, so it's pretty nice, pretty quick for commissioning, and these controllers can be used with any type of VVT zone that you're going to see, series or fan powered or single duct. You can adjust it, an auto-generated graphic just like that. The next two items we have on here are damper size. And this is important for calculating the control of the rooftop unit. So we mentioned linkage before. The way linkage works is the master zone pulls the slave zones, and then for VVT it will actually look at whichever zone is furthest away from set point. It will read that value and it will send that information to the rooftop and say, rooftop, you run off of that space temperature and those set points. So if I have my 5 zones and 4 of the zones are at 72 degrees and the 5th zone is at 76 degrees, because my 72 degree zones are within set point, I'm not going to worry about those. I'm going to look at the one that's in 76 degrees and I'm going to go into cooling mode because I'm above my cooling set point. Once that drops down, if another zone goes out of whack, it's going to run off that zone. It's going to run off whatever zone is furthest away from set point. The thing with the damper sizes is it actually weights these values, these votes for whichever zone is furthest out of whack based on size. So if you have a 12-inch zone damper and 4 6-inches, that 12-inch you want to have a little bit more of a weight in choosing if you have in choosing how the rooftop reacts, because that's a bigger zone with more air coming out of it. Okay, so that's where you type in damper size. This in inches would be for a round duct, and the damper size in square inches would be for rectangular, to choose which one you have. The next line you got is an external actuator enabled. This would be if you were slaving an actuator off of it, off of the controller. In order to slave an actuator, you have to use the hot water analog output that we mentioned before, that 0 to 10 volt signal. So you cannot have a hot water valve, modulating hot water valve, and a slave actuator off one of these zones. But in order to set it up, you just change this to enable. You wire to that output on the controller, and your actuator will modulate based on the actuator on the zone control. The next one we got is heat type. You have a couple different options. You can do modulating, where it'll run off that modulating analog output. You can do two-position valve, where it'll run off of those heat stage outputs that we showed you. And then you can do two-stage electric heat, or you can do a combination of both. Just so you guys can see, I'm going to show you real quick. I'm going to look at staged. I'm going to hit OK. And I can choose if I have ducted heat or I have non-ducted heat. If we look at the graphic for ducted heat, you're going to see it's going to show a heat coil in the graphic with my two stages. If I choose non-ducted heat, I'm actually going to show on the graphic a piece of baseboard heat that we will be controlling. So you can control a duct heater with these or a baseboard heater up to two stages or modulation here. So you can see I have my little auto-generated baseboard heater with my two stages of heat. Now when these units are voting, or when they're going into requiring heating or cooling, before the zone is going to send the heating vote to the master, it's going to enable its reheat first. So reheat is the first stage of heat. If that's not maintaining the space, and the space gets so far out of whack that it votes for heating to the rooftop, then the rooftop will go into heat and actually discharge hot air to the zone damper. Okay. All right. So you can see we can turn heat completely off. We can take out the number of stages, 1, 2, or 3 stages. The third stage runs off of the fan output. So if you can only have 3 stages of heat control if you do not have a fan on your zone damper. Okay. But I'm going to shut off the heat because we don't have any on this one. You can choose your valve type. If you have an open-closed valve, you can show it as normally closed or normally open. Usually with hot water valves, in my experience, they always like to fail open, so I would switch this to normally open. But I don't have a hot water valve, so it doesn't really matter. Optional sensor type would be if you wanted to do any type of humidity or CO2 control. CO2 would be for demand control ventilation, or humidity would be for dehumidification in the rooftop, the humidizer option. You can only do one of each. The controller only has one input for one of each of these. But if you set it up, I would say, let's say I want to do relative humidity sensor, I would have to enable the control as well. I hit OK. Give it a minute here to take the load. And now if I look, I can see I have my input for 0 to 5 volts, ranges from 0 to 100% on my humidity. And if I look on the graphic here, it's going to display my humidity value here in the space. You can see my relative humidity. Now I don't have an actual humidity sensor wired into this, so that's why I'm reading 0, but that's where it would show it. And based on that value, it will do similar voting with the rest of the system for humidity control, for the dehumidification. And the same goes for demand control. If I put an IAQ sensor on there for demand control, you can see now my range goes from 1 to 5 goes to 0 to 2,000 parts per million of CO2. This would just be based on the sensor that you have. Okay? And that will show up again on the graphic in the indoor air quality of parts per million. Okay. Last thing on the service configuration page is the minimum set point separation like I talked about. Here is where you can change that value. I can go to value of 2, hit OK, and now I can go down to 70 and 72 for my heating and cooling set points, where before I could not. So this is where you would change that value. The rest of this page is not that important. It's about if you're sharing values for space temperature, what you can do is you can have 2 zones that can run off of one space temperature. You set it up as a system space temperature. You can do that for humidity and air quality as well. But not that important. If it comes up, let us know and we'll teach you how to do it. But it's pretty simple, pretty straightforward. What we want to click on next is this pressure dependent control. And this is where we're actually going to commission the actuator on the zone controller. Okay. So I clicked on pressure dependent control. I want to go to the details tab. Okay. Now, starting at the top here, you can actually choose if you want your damper actuator to close clockwise or open clockwise. Okay, you have the option. It depends how you install it on your damper, but you can change that. Okay. Obviously, it's a good idea to keep consistency throughout, but you have the ability, once you slap that actuator controller on the damper, to change the direction if you installed it incorrectly. Okay. Looking at our damper positions, we have our cooling min and maximums and our heating min and maximums, and then reheat values. With a VVT system, you always want your minimum percentage on the zone damper to be 0. Okay. The reason for that is because you can do both heating and cooling based on the boat. You don't want to be sending hot air into a space that's already hot. Okay. Let's say that the rooftop is, the boat is going into heating mode, but three of the zones are actually requiring cooling. They just aren't too far out of whack. We don't want to be discharging a minimum amount of hot air into those zones. We want no air going into those zones at the time. Now, you still need to meet your ventilation codes, but with under 20-ton systems, I mean, it's not that important relative to big VAV systems. So ideally, you want to put this at 0% for both your minimums here. So I would change those to 0, hit apply. Your reheat minimum, this is what you want to set up so you don't trip your duct reheat. Okay, so if you have, most electric reheat coils are going to have a trip if they're not improving airflow. You want to balance your system at this percentage so that you're not tripping that that electric heat coil. And then for your ventilation position, that's just what value you're going to. If you are not requiring heating or cooling, the damper is going to go to that position. So 50 is kind of a lot. You might want to back it down a little bit, but it's really up to you what it's designed for and what you want to throw in there. The big thing we want to look at here is the calibrate damper close, calibrate damper open. What we need to do is tell this zone damper that once you go to fully closed, this is your fully closed position. Once you go to fully open, this is your fully open position. Okay, and it has feedback built into the actuator so that when the actuator is moving, if it is already reached its furthest position, even if it's not at 100%, say, it will read the feedback and it will automatically adjust itself to that being the fully open position. Okay, so if I hit calibrate open here, my damper position is going to start opening. You're actually going to hear your damper move and see it move. Let's say that around 50%, I have a damper actuator. I'm sorry, I have a damper that's only like a 45 degree damper. It's not going to spin 90 degrees, which the actuator is set up to do. Once my actuator reads feedback on the damper, it's going to automatically jump to 100%. And from then on, once I've calibrated it for fully open at that value, it's going to only go to that position for full open. Okay. And an added built-in feature that we have on these actuators is little screw locks to prevent the actuator from fully rotating 90 degrees. So if you have a 45 degree damper, you can put in those screw notch locks to prevent the actuator from overspinning and potentially damaging your damper. So there's two safeties built into it here. But once it is calibrated fully open, I read 100% on here. I would actually want to physically look at the zone damper, see that it's 100% open. Then I would know that I'm good to go on that calibration. I would hit apply, and then I would want to do the same thing for the damper close. This is an awesome pop-up that's built in here, but what you want to do whenever you're calibrating the closed damper is shut off your air source, okay? Because that will ensure that your damper can fully close, and you want to know, it needs to know its fully closed position in order to calibrate properly and to range properly. So you want to shut off your air source first, then you hit calibrate damper closed. You're going to hear the actuator move. You're going to go up in the ceiling. You're going to make sure the actuator is fully closed, the damper is fully closed. Once this is done, this is going to read 0% here. This will say done. And then what I want to do is put it back into automatic control. It will run based on its temperature in the space. So all these cool heat max, heat mins, you don't need to worry about those, but you can put them in if you actually want to measure CFM airflow, if you're working with a balancer. but the unit's going to run properly without those because it is a pressure dependent system. It's just going to modulate from 0 to 100% based on space temperature. So you can see it says auto zero completed. I hit automatic control. Now my actuator is set up to run from 0 to 100%, and I'm set up, configured for how I want to be configured on here, and my damper actuator is set up to run. Okay, so this zone is going to run standalone by itself right now. Okay, it's not communicating with the rooftop, it's not communicating with the bypass, but it will read whatever supplier temperature it has. Based on that, it'll read its space temperature. If it needs cooling, it'll look at the supply. If the supply will provide cooling, it'll open. If it won't, it will go to closed. Okay. The only other thing we would want to do would be to just put a schedule on this guy, which we could do under the Schedules tab, which is the same with any type of field assistant or iView system. You can add different types of schedules. This would just be a normal schedule. I want to put in Monday, Tuesday, Wednesday, Thursday, Friday from 8 to 5. So now I have a time schedule on this. It's going to run off this time schedule. You can see that it's actually downloading that information from my computer to the controller. So that's stored on there. If I go back to the Schedules tab, it's going to show up now as Monday, Tuesday, Wednesday, Thursday, Friday. Okay. So now I have a time schedule. After 8 o'clock, I'm going to go into night setback. The last thing I want to set up here would be linkage, okay, so that my zone controller can communicate with the rest of the zones and the rooftop unit. In order to do that, I need to go to my master zone, which I'm on right now, address 15, the highest zone on there, and I want to go to this tab called Linkage, okay? Now, like I mentioned before, linkage is the voting system, the communication between the air source and the zones. Right now, you can set up what type of linkage you have for each zone. Okay, so they all default to slaves, but you want to make the highest address the master. Okay, and I want to set it up for a VVT master because this is a VVT application. I set it up for VVT master. I hit OK. Now, there's two more steps that you need to take in order to set up linkage on here. Okay, the first step is to go to the linkage collector hyperlink right here. If I click on this, my linkage collector is technically my linkage master, okay? And I need to tell my master how many addresses below itself it needs to count down in order to pull all of the slaves or all of the providers is the politically correct term here. So in this number of providers slot here, I want to put in, including the master, how many addresses down I want to count, okay? So for this system, I just have the master and the bypass. I would put in number 2 here, for I would have 2 providers to my master, including my master. The master counts as a provider to itself, okay? So if I had the 5 zones, like I said before, going from 15 down to 10, I would actually type in a total of 5, or a total of 6 for 15. So I would have 15, 14, 13, 12, 11, 10. And that would be telling my master to say, hey, look at yourself as the highest address and then count down to address 10 and pull all the information from each of those zones. Okay. So once I type this in, I want to hit apply. I hit close. You can see my linkage status is still saying not active. What I need to do now is I need to tell the VVT master where to look for its air source, what address to look for. Okay, so I want to click on Linkage Provider, and I'm going to make this box a little bit smaller here. And down here where it says air source, this is where you want to type in where the air source address is. Okay, so we saw before I set it up as address 21. I'm going to type in 21 here. The other thing you need to do is type in what network you're on. Okay, when you have more sophisticated systems where you have different networks with different zone controllers connected on there, you can actually set up air or masters to reference air sources on different networks, and each network has to have a network address or network number for itself. So you need to type in what network number you have on here. And you can see on the left-hand side it says network 16101. That's my network number for this system. That's what's going to auto-generate whenever you have Field Assistant connected to a system. It's going to be 16101. So I type in my network number 16101, my address is 21, I hit apply, I hit OK. Now my VVT master knows how many slaves to look for and what air source to look for. Okay. Now it still says not active, but it's just going through its logic, and it's going to say active in a second here. If I go to the graphics tab, you can see my linkage COM now actually says active. Okay. If I go back to linkage, now you'll see my linkage is active. If I go to my rooftop unit, I haven't touched the rooftop unit with any programming, right? Previously, linkage was not active on this. Now, since I made that change on the master, it's going to say linkage is active. And it automatically knows that because I pointed the VVT master to the address of the rooftop. Okay? So, real quick, I'm going to show you what you can see the values that the VVT master is actually polling, actually looking. If I look, or actually reading, I'm sorry. Click on linkage collector here, and I go to the details screen. You can see the number, the addresses, and what values they're sending to that linkage master. So you can see I have my network 16101, address 15. I'm reading all these values from that zone. And from the bypass, I'm not reading anything important because it doesn't have a temperature, but the bypass needs to be included on there. So these are the live values that we're reading, and these values below are the values that I'm getting from the air source. So I'm reading from the air sources in mode 8, which I believe is heating, and it has a supplier of 70 degrees and an outdoor air temperature of 85. I'm reading all that information as the master and then sending that information to all the zones as well. Okay. And if I look at the rooftop unit, I can go to linkage and I can see what values I'm getting as the air source over here. Just takes a minute here. But you can see that I'm reading a space temperature of 72. My set points are 70 and 74. Okay, unoccupied. So if I go to my zone and I change my set points to 78 and 65, because linkage is set up, this is going to correlate, this is going to move over to the rooftop unit here. And you'll see actually on the rooftop unit right here, these values are automatically populated of 65 and 78 because it's running off of that zone. Okay. Another important thing to remember is with the scheduling, we put a schedule on that VVT zone. Because linkage is now set up on this system, the schedule is going to, the rooftop unit is going to run off of the schedule of the zones. Okay, so you don't need to put a separate schedule on the rooftop unit. It's going to run off of the VVT zone schedule. It automatically does that through linkage, so you don't need to put a schedule on the rooftop unit. I guess I'm running kind of overtime here, so I guess we're going to have to cut it here. There's not much more to do other than configuring the bypass. The bypass, what you want to do is you can set up your set point for the bypass controller of how much duct static you want to set. So, I'm sorry, you can do it on the graphics page. If I just click on duct pressure here, oh, wait, no, I'm wrong. If I have to click on bypass control here, I'm sorry. I should have known that. This is where I would type in whatever duct static pressure I would want to maintain in the duct, and then I would do the zero calibration and the fully open calibration as well. Okay, so I need to stroke that actuator as well to make sure that it can do its full range and I can get a good pressure reading out of it. Okay, so you do the same thing with the bypass controller. Other than that, you would just set up your minimum maximum for cooling, and that would be ready to go as well. You don't need to put a schedule on the bypass. It's going to do its thing no matter what. The reason you have a supplier temperature on here is to prevent short cycling of air with VVT systems. The location of these, you don't want to be bringing really hot air back to the unit too fast, or really cold air, because you could potentially freeze a coil or burn something up here. So if you don't have a good bypass placement, there's a logic built into this system to start to modulate that damper closed if your temperature is getting too high. You're bypassing too high air or too low air to protect your rooftop and your air source. But other than that, I'm sorry I ran overtime, guys, but there's a lot that you can do with these controllers. We are having some training classes coming up in October that if you guys are interested, we can send you the link to sign up for. But if there are no other questions, thank you very much for attending. And if you guys have any questions, please feel free to contact us. I can shoot you an email or you can contact me directly. So thank you very much.